Dear students, welcome to Theory of Computation course. Course code UIT IT 404. And this is Dr. K. Praveen Kumar, Assistant Professor, Department IT. I'm going to teach you Theory of Computations. So preliminaries required for these subjects. The students should have basic knowledge and review on mathematical theory, and also should have principles of mathematical inductions. And the textbooks we have to refer for this course is John E. Hopcroft, Rajiv Motwani, and Jeffrey D. Ullman, Introduction to Automata Theory Languages and Computations. Pearson edition, third edition is preferable. And second textbook is Theory of Computer Science, Automata Languages and Computations, written by Mishra KLP, Chandrasekharan N. So it is preferable, it is mandatory to purchase these textbooks, as this course is core subjects for the IT students. And these are the reference textbooks. You can refer these textbooks from the library. And this is a 3-lecture course and 1 tutorial, and it's a 3-credit course. And of course, you already know it, minor examination 2 will have 10 marks, and MSc 1 and MSc 2 is a maximum marks of 30 marks, and final examination is of 60 marks. Right. So the addition information for this one, and it's a basic for the translators, assemblers, interpreters, and file concepts in Java, C, C++, and some concepts in TOCR, finite automata, and these are the main concepts of theory of computation: finite automata, deterministic finite automata, non-deterministic finite automata, regular expressions, writing grammars, context-free grammars, making context-free grammars are the main important concepts of this course. So there are few self-learning topics are there, and students should be able to solve the concepts of finite automata, DFA, NFA, regular expressions, grammars, ambiguity grammars, context-free grammars, construction of syntax trees, and assignment status, Boolean expressions are the concepts. And students should learn the concepts of files, of C, C++, and Java programming. And you can also know that you also have to know the types of compilers. Right. So the course project is given to you in the course web page, and the course project contains some design of a mini compiler, which is an attempt to reduce the complexity of the compilation process to such comfortable level that an average computer student can easily acquire a grip on the basic compiler construction. And the mini compiler is having 3 phases. One is lexical analysis, syntax analysis, intermediate code generation. And even these phases are simplified. Syntax analysis and error handling are done on the output of intermediate code generation phase. The interface can be designed by using C, C++, Java, and .NET. You can use any of the interfaces, and backend code can be C, C++, Java. Right. So outcome of this course project should be design in mini compiler and tiny compiler for a programming language. And if the sample program is valid, C program, then the user can execute it using a command at the command prompt in MS-DOS. Lecture outcomes of this subject, and the course will be develop students' knowledge in formal notation for strings, languages, and finite automata. Lecture outcome 2 is properties of regular languages types of grammars, and applications of context-free grammar. Lecture outcome 3 is equivalence of languages accepted by push-down automata, that is PDA, and languages generated by context-free grammars, CFGs. Lecture 4, computability and non-computability and decidability problems in Turing machines. Course outcomes. Upon completion of this course, students can be able to write a formal notation for strings, languages, and finite automata. Upon completion of Unit 2, student can be able to design context-free grammar to generate strings of context-free language. Upon completion of Unit 3, student can be able to determine equivalence of language accepted by push-down automata and languages generated by context-free grammar. Upon completion of Unit 4, student can be able to distinguish between computability and non-computability, decidability and undecidability in Turing machine. These are the Unit 1 concepts: automata theory, finite automata. In the finite automata, you're going to learn about deterministic finite automata and non-deterministic finite automata. And the regular expressions, languages. Coming to Unit 2, properties of regular language and context-free grammars and languages. In the Unit 3, you're going to learn about properties of context-free context-free languages, the normal forms for context-free grammars, pumping lemma for context-free languages, closure properties of context-free languages, decision properties of context-free languages, push-down automata. In Unit 4, you're going to study about Turing machines, problem that computer cannot solve, the Turing machine, programming techniques for Turing machines, and undecidability, a language that is not recursively enumerable. And these are the parts of active learning. So you are expected to take ownership of your learning. You are expected to be an active learning. Textbook reading is an essential part of your course learning. And as it is mandatory, you have to purchase your textbooks and you have to bring it to the classroom, the textbooks with your name and roll number printed on cover page. And I have already prepared OBLS, outcome-based lecture schedule. So you can download it from the course webpage and you can go through with it. The different self-learning topics also listed, and I'm going to upload relevant material to the self-learning topics. And you also have to prepare your own notes. And of course, I'll give you notes, but you have to prepare your notes. That will be the best practice. The classroom discussions, CDTs, read the textbook for the topics mentioned in the OBLS and relevant resources and lecture summary uploaded in the course web. Attend the class with complete preparation to take part in active learning by participating in classroom discussion. And 3-page summary of each SLT CDT along with the lecture level practice problem, LLPs, is uploaded in the course web page. So real world problems, conduction of tutorial classes, tutorial matrix, course web page, course programming assignments, special assignments, course projects are the part of active learning. And these are the knowledge, skill, qualities required for this active learning. So these are the LOs and course outcomes. So this is all about the information regarding the course theory of computations. All the best, students. Happy learning. Thank you.